Hello everyone! Today we will take you to see how we can in the Wings engine to create a real interactive calculator. And we'll finally add this calculator to our asset library so that we can make some real instruments. And they have a screen display. Let's first take a look at the effect of this calculator. This calculator is a very simple calculator. We have some buttons, including a switch. We can use it by... Okay, we first need to click on the entire preview interface and not enter an editing interface. We can see the effect. Click it and it will turn on. Then we can do simple calculations. 8 plus 3 equals 11. Okay, so this calculator has the same logic as a real calculator. Logic. So in the mountain glasses, how to implement this logic? And finally add it to the asset library. And turn it into an existing device asset. Let's use this as an example to show you. Okay, let's double-click to take a look at this calculator. This model we used to create it. A GLB model. And finally imported into our sand glasses. After importing it, we can take a simple look. It is divided into a screen with a display screen on it with such a material. And then we have some buttons. Of course, we made some errors here, such as 8 divided by 0 will show errors. We made this separately. Of course, you can also display it. These buttons are just some different buttons. First, we hope to achieve the effect of this button. The effect of this button. The effect of pressing it down. In fact, we don't need to do 2 opens, but directly in our model. We can achieve it through interaction. Let's take a look at one of the buttons. We click on the interaction. We can see that it has 3 interaction events. The first interaction event is to press down the button. This effect to the 2 opening events. We pass the name clear as the parameter. Of course, we don't necessarily need to use this interaction. We can also directly in the secondary development to listen to the buttons event. Of course, using interactions may be more intuitive. We are using interaction here. And the second one, when we press and click to push the position of our components down a little. And then you can see these 2. Our interaction seems to be simultaneous with the previous actions because it needs to be sent to Tukes and operates to change its position. After changing the position and pressing it down, it needs to bounce back by itself, right? Then we need to add another interaction, so that after we press it down, to bounce up again after the previous interaction. Then this function is completed. We just need to copy this interaction for each key. And copy it. This interaction we can achieve after we click it. It can have a press down effect. Okay, after we have the button, how can we realize that when I press down this thing to show on my screen? This is a very important content of this class. This requires us to use the to open. We click on the model. We can see that on the calculator. There is a to open code. Okay, let's go to the code. To take a look at the code, let's click to open it. Okay, let's take a look at this code. The core of this code is to implement two parts. The first part is the real addition, subtraction, multiplication, and division. With the logic of real addition, subtraction, multiplication, and division. But if we encounter some more complex, our devices, it may involve more complex, such interaction logic. For example, we may have our electric meter, which wires it might involve, which wire to connect to, and what kind of different logic will be displayed. This requires you to use it yourself, our two-way code. To implement it, what we are demonstrating here is a basic implementation of a computer. That is, we added this button before. If it's addition, we just use addition and subtraction. This is a very simple one. Synchronous logic. The more complex part is how to display the results of my logic on my screen. For this, we need to use off-screen functions in our two open source libraries. Function. First, when we initialize, we need to create an off-screen canvas. Off-screen canvas. This canvas will not be displayed on the screen, but it is a standard. External canvas. We can use the context of our canvas to draw various contents. For example, we can draw our text, to grab text, or draw some pots, or draw some circles, and so on. In fact, all that we can achieve on the web. In our code, here I need to draw text. Of course, because here, this word is a special font. So we use the LCD font to process it directly. Of course, this LCD is ours. Is built-in in the flash eyes. By default, you can use the system fonts because our computer has a special case. So we need to use LCD after we initialize the canvas. We can call it later. Here we can. We directly put it. We made it a private. As a private property. Secondly, we need to get the canvas. The material of the screen. Because after the canvas is finally drawn, I need to set it to the screen. Let's see where the material of the screen is. There is a display on our screen. We enter the style of the display. We can see that it has basic colors. We finally set the canvas. To this texture, then it will be displayed. Okay, let's see how to set it specifically. We have a drawing screen method here. First, we need to draw. We drew our entire result on our canvas. We set the fonts, colors, and alignment, and so on. Finally, we will draw such our text. Finally, we converted the drawn canvas into a blob. Then, after getting the blob, we create the UIL. Set this UIL to the one we got before. The option of the screen material, which is the albedo texture. As for how to get the RB settings, in our other tutorials on secondary development, we actually explained it. That is, we can right-click here, left-click on the 3 dots. Then we get the call code example. We can see how to set it. Okay, and then where can we get this screen canvas material? Where can we get it? We can use by using our built-in to get children. To get the screen piece. This screen piece is calculated by piece because we are currently is hanging on the top layer, hanging on the calculator. We can continuously get children and compare their names to get the material. After getting the material, set its options. We can replace the font through this secondary development code. We can achieve the button and the logic of the entire computer to achieve real-time calculation. Let's take a look at how to put our model into our asset library. We just need to put this model, all our interactions, including our secondary development, must be attached to this, or its sub-elements. It can't be hung outside. If it's outside, it will be lost when we put it in the asset library. We must place our secondary development, the root directory and below of this element, to place our secondary development code and interactions. In addition, if our interaction, such as here, and interactions, if it controls other elements outside, it will also be lost. It can only control itself or the entire model that enters the asset library or elements inside the model. Right-click on it and add it to the asset library. Then we select an asset directory. Select all and then click OK. Like this, we went back to our asset library. We can see that here. There is a calculator. We have already added a calculator before. Let's put it back again. Okay, this calculator. Everyone. Sometimes our cover may not be recognized very well. You can change the cover yourself. I won't change it here. With this calculator, in other projects, we can create a new project here. After creating a new project successfully, we can put this calculator as an asset into our entire project. In this way, in other projects in the future, we need to use the same device. And we hope that this device to have its own behavior. We can reuse it through this pattern. Let's click on this model and find the asset library and find this calculator. We click it, and it will be added to the entire screen. Let's take a look at this. Does the calculator have all the interactions we just wrote? We click Exit, and then click 9 times 6 equals 54. This is because there was a bit of a delay just now. You can see that the logic of the entire calculator has been realized. Okay, today's class is to teach you how to add our calculator with its own logic and has its own screen into our asset library and reuse it in the future. Okay, thank you all.